Hello, welcome back to the next part of the lesson. So now we're going to look at how to find mass using the same equation here. So in the previous session of the lesson, we are looking at how do we find the weight. So we have been using this equation weight equals mass times gravitational field strength to find out the weight. So what if we're finding out the mass instead? So we're not looking at the weight, we're looking at the green one, the mass. What if we're trying to find out the mass? In this case, we need to rearrange the equation, or we can say to do the reverse of what we have been doing. So to rearrange the equation, you would move the gravitational field strength to the other side of the equal sign. So you move it from the right to the left, and if it is times, it becomes divided, which means you do the reverse. So to find out the mass, you need to move the gravity or gravitational field strength from the right-hand side to the left-hand side and do the reverse. So W, weight, divided by G, gravitational field strength, equals M, which is mass. The unit stays the same, so weight is still measured in newtons, gravitational field strength is still measured in newtons per kilograms, and mass is still measured in kilograms. So the unit doesn't change. What you have changed here is you only moved the gravitational field strength from right hand side to left hand side and do the reverse. So you, instead of doing times, you do divided, and you now divide weight by gravitational field strength. So this is a version of the equation, the same equation after rearrangement. So you have rearranged it already. So mass equals weight divided by gravity. For example, calculate the mass of a 525.1 Newton astronaut in a gravitational field strength of 8.9 newtons per kilogram. So what do we do here? So mass equals weight divided by gravity. So you do the weight, the green one, divided by the blue one, which is the gravitational field strength. And you go to your calculator and you should find the mass equals 59 kilograms. So this time we're finding out the mass. The mass is always measured in kilograms. So the mass is again the measurement of how much matter, how many atoms there are inside an object. So the mass should be measured in kilograms. Okay, let's move on to another example. It should help with your understanding. So the second example is this one. We're still using the rearranged equation, mass equals weight divided by gravity. So the example is, calculate the mass of a 670 Newton astronaut in a gravitational field with a strength of 9.8 newtons per kilogram. So again, you use a rearranged equation because the question is asking you to calculate the mass. So to calculate the mass, you do this equation, mass equals weight divided by gravitational field strength. You do 670 newtons, which is the weight. So again, weight is measured in newtons, divided by the gravitational field strength, which is 9.8. So you should get 68.4 kilograms. Again, mass is measured in kilograms. Okay, so what happens now is I would like you to move on to the next session. That means the questions down below, and I would like you to complete the questions. Please do include the numerical answer and to include the unit at the end. You need to decide if you need to rearrange the equation. That means if I go back a little bit, you need to decide if you need to use this equation to find out the weight, or if you need to use this equation to find the mass. Again, if you're finding out the mass, you need to rearrange the equation, do the reverse, so you do weight divided by gravity. If you're finding out the weight, you only need to find out the mass and times it by gravity. Okay, I will stop it here, and I would like you to take out a calculator and attempt the questions below.